So now, here, what I'll do is I'll try to explain you one more project. This is related to heart disease classification. It's the same project, but the same steps which we followed, but the following the steps is bit different. However, we took, however, we worked for diabetes. Like in a similar way, we approach it in a different way. Now, once again, have to take it Kaggle. I have to upload Kaggle.json file. Use files, Kaggle.json. I'm opening this file. Now I'm adding one more code block here. I'll specify the Kaggle.json link here. So for that, we have to go to datasets. We have to search for the dataset. Or this is prediction. I'm clicking on datasets. Actually, we'll be having many datasets here. We'll check which dataset we have taken. Anything. Like I will open the first one and we'll see. If most of the people worked on this now. We'll check whether it is the dataset or not. So it's 3 KB only. Here we'll be having heart disease prediction, CSV, like age, sex, same features will be having. We'll see whether it is the dataset or not. Okay. So what I'm doing is I'm taking copy AP command. Here I'll keep it, and in front of it I'll add exclamation mark. It is downloaded. It will be in the form of zip file. We have to unzip it. Exclamation mark, unzip, space. We have to specify this path. Okay. Copy path. I'm running this one now. As you know, next step, it will be unzipped and there will be a data set. You can see hard prediction.csv. Okay, copy path. Okay, I'm taking this file. So prior to that, I'll check whether the same samples are available there or not. Okay, so now here I'm importing essential libraries. Okay, I'm checking the files. So here we have to specify our file. Actually, whatever we copied, we have to specify that thing here. Okay, so as this content and everything is not required, why means we are reading the file from local. So if we keep it also, it won't create any impact. Okay, so now we are reading the data corresponding to data set. Now I'll try to check this feature whether it will give same values or not. Okay, Control C. I'll check the code. Okay, you can see it is having more parameters. Okay, we'll take same data set. It means what I am going to say here is it is not the data set which is having same features here. Okay, so if you take this data set and you can work upon the same data set as well. If you take this data set now, however we are being processing here, you can do same processing, but here coming to the heart disease column, we'll be having presence and absence. To convert these values in the form of categorical values, you have to apply label encoder technique. Then this values will be converted in the form of 0 and 1, and you can perform further analysis. So I don't take this data set. As I already worked on this project now, I'll take the data set which we worked previously. Disease prediction data set. Let's see. PKP, I think this is not the one. We'll see. Disease prediction. Yeah, we'll see this one. 60 KB. Okay. We'll see the features of this. I will see the column so that we'll understand. So column means it will give you column names corresponding to the data set. Not giving. I'm going to detail. Okay. I hope like I took this data set now. Like I'll go to that one. I think file name would be, yeah, this could be the file. So I mentioned the data set here in this, I think. Yeah, this is the one. Oh, it's a different one. Huh? We'll see. Yeah, here it is. Content API CSV file. All this is data set. Okay. So different data set I have taken. Yeah, this is the data set which we have taken. We'll take this name exactly so that hard disease data. Search it so that I'll get it. Okay. Hard disease data set for detecting if the person has a disease or not. Okay. Is it the data set? Not the data set. The data sets. I'll go to this one. Which one is the correct one? Yeah, you see a hard disease data set. Mostly this could be the correct one. We'll see. Copy API command. Here I'll replace this path with the save. I have to unzip this one. This is .zip. I think this could be the correct one. Yes. Reading this one. So, yeah. Hard disk dataset uca.csv. We need this file. We'll see. I think it is also a not correct file. The file name would be hard.csv. No, it's not the one. Give me a minute. I'll check and I'll let you know quickly. There's almost stop it. We'll see. I think this would be the correct data set. Okay. So now we'll see. Copy API command. We can do with the other data sets as well, but we have to do few steps on our own so that it will take some time. Yes, it's working. We have to unzip this one. Unzip folder it is. Hard disk is prediction says it's not the one. Hard disk is data.csv. I think this is the one. The part. Unzipping it. Is it? I'll do one thing. Delete everything, or else I'll cancel the runtime. Disconnect and delete runtime so that we won't have the previous data. It's completely gone. Now we're running from starting onwards. It will connect to the cloud once again. So we have to choose Kaggle edges, and yes, we are choosing it. Yes, we did it. Now we have to do this one. Once we download now, we can see that file here. So this is the correct one. Copying the path. I have to unzip this one. Yeah, we got the file. File name is same, whatever it has previously, r.csv. Now I'm checking the name r.csv. Okay. Now if you look at the head, you'll see top 5 rows. You can see this is a data set which will look as is in the previous project file. It means we took the same data set. Okay. So now I'm checking this once again. Positions are changing. Like initially, previously you can see zeros, ones. Now you can see zeros. Okay, but the column names would be same. Now what I'm doing is like randomly I'm checking whether there is a value one in output column or not. Target means it is an output column. Okay, which contains like whether the person have heart disease or not, that information. As you know, the describe method, which will give you statistical behavior of your data. Okay, it's giving statistical behavior. As you know how it will be. Okay, you'll understand that. The next info method, it will give you information regarding the data set, like how many values present in each and every column, that information. Okay, so we're not having missing values in any column, and the data type mostly integer or floating point values. Okay, luckily we are not having missing values, so we need not to clean missing values. As we have in a Kaggle, we'll be having description corresponding to each and every feature, as I am framing that thing in a good message, so that by looking at here you'll understand which column corresponding to what. Age, sex means gender column, CP means chest pain type, like there will be different type of chest pains, like what are they, and which value corresponding to what. One means in the data set, one means typical agnia, two means atypical agnia. Like that we'll be having different categories with the numbers. Okay, like that whatever the different features are available and what is the description of that features, we are representing same thing which is available in category here. Now we are checking the target column, we are describing the target column. In the target column, totally we'll be having 1025 samples. Out of all, like 50% of 51% of
See,
samples. So please keep your microphones in mute. Okay. So now here, like what I'm doing is I'm describing the output column so that I'll get to know whether our data set is balanced data set or not. You can see out of 1025 samples, 51 samples are like corresponding to heart disease patients. Remaining 49 are corresponding to non-heart disease having persons. It means the data set is balanced. We can use accuracy as a performance metrics. And we are checking unique values corresponding to each and every column. Target means output column. In the output column, we'll be having only two categories, 0 and 1. Coming to chest pain type, as I told you, we'll be having four categories, 0, 1, 2, 3. As in a description, we saw the categories with the 1, 2, 3, 4 now. You can understand like 0, 1, 2, 3 like that. 0 means typical, 2 means atypical, sorry, 0, 1, 2, 3 like that you can understand. I kept there 1, 2, 3 now. Here it is 0, 1, 2, 3, right? There also you can keep 0, 1, 2, 3. Chest pain unique values will be having four different types of categories in chest pains. That is the purpose of n unique function. It will give you number of unique values corresponding to any column. The next, so we are sorting the values corresponding to, we are checking the correlation values. Just like previously we represented correlation now. Now we are checking that correlation values in the percentage here. Same thing you can plot as well. At the bottom we'll do that. So it's just a pair plot, like pairwise relationship between each and every feature. Each and every feature impacting how much other feature. To know that relationship, we'll be having pair plot, as it will take some time to run this, as it needs to process all the features. Okay. It means it will give you a relationship between each and every feature in the graphical format. So previously we saw that with the heat map. Now irrespective of heat map, just we are plotting how one feature impacting other feature. We are plotting that in a graphical fashion. Better like every time you can check a runtime, and while running it, don't change it. But previously, if you kept it to T4 GPU, it would be bit quicker. It means it will run on GPU, na, it will be much quicker instead of CPU. Better once you run or once you work upon big project, na, better to change that. And it is still running. If it is GPU, it would be complete as of now. So like we'll be having how many features we'll have, that many columns it needs to plot. Still, it is taking some time. Yeah, it's done. So now you can see how each and every feature impacting. On the x-axis and y-axis, same features, however, we considered previously, and we are comparing pairwise. Similarly, like based on each and every feature, here in this example, what I am doing is how age column, like a means a sex column, means gender column, impacting all other features. So in the gender column, we'll be having two categories. One is male, another one is female. Based on that, we are looking at a pairwise relationship. How gender column impacting all other features. Okay, that information we are looking at here. Similarly, we can do it for all other features as well. Similarly, previously we plotted heat map. Now, same heat map I am plotting for our data set. In this data set, we'll be having more and more columns. That's why you'll get it much in a robust fashion. Means you'll get all the features in a very closer format. We'll see till this execution completes. Yes, I thought of forgetting to change it to GPU while starting it. No worries, like no more executions will take more time, except this. Similarly, next pair plot, as you can see, this is also same thing. And target, coming to the output column, I'm visualizing how much each and every category samples are there. I'm running this. These graphs are not that much required. You can check it, check them later. For more visualization for the project, we'll do that. So coming to the count plot, you can see why like now it won't come. We'll see once the execution completes now. We'll see from here. As you can see, it's a heat map, like how one feature impacting other feature. You can check that thing, and it is a correlation plot for each and every feature. As we'll be having more and more features, that's why this graph is looking bit robust. As to plot this correlation plot, now you can take help of same code, whatever we used in a diabetes project. Okay, but that is one approach. This is another approach. That's why I'm showing two projects corresponding to machine learning. Okay, so now we are checking this one. It won't give output. I think here we have to add y equals to y. Still, the top portion is running. That's why it is taking much time.
Sir, your voice is not audible.
Sorry, I'm speaking in mute. Thanks for reminding. Okay, so from there onwards, you are unable to hear me? Okay, no worries. So the thing is here, like we'll be having like we checked each and every category values count. As if you get any errors now, you will be having internal AI. You can take help of internal AI. At the bottom, you will see that suggestion. Okay, a percentage of each and every category we saw, and number of unique values we are checking for each and every category, and the percentage of values corresponding to each and every category. Okay, so you can see that percentage here. Now chest pain type, you can see here, control Z. So what are the different types of chest pains we'll be having in the data set, and what could be the percentage of each and every category. Okay, so from this you'll understand. The next describe method, as you know, which is used to get statistical behavior of the data. So total samples, mean of the specific column, and average of specific column. The unique values corresponding to that column, it will give that thing. And here we have to add the values. X equals to this one, and Y equals to this one. We have to specify the features nowadays. Okay. Similarly, for this, what the hell? Yeah, we'll check the unique values corresponding to this. We'll be having 3102 coming to the resting CG. Okay. The next here we have to specify X equals to this one, mm, Y equals to Y. For each and every category, how many values we are having, we are checking that proportion here. Coming to this, we are checking in each and every category how many types of values are there, and we are plotting bar graph for each and every category. So now what I'll do is I'll run this portion so that we'll get an error now. We'll see how to resolve that error. To resolve the error, you can take help of, see, you got an error. So now to resolve this error, what you can do is you can click on explain error. It's an AI which was developed by Google Colab. Okay. So now it will give you a suggestion, Gemini, SNS bar plot. In the bar plot, what you have to do is you have to specify X equals to something and Y equals to something so that you'll get an output. Directly, you can copy paste this thing and you can keep it there so that you'll get an output directly. So if you are lazy enough to solve this kind of problems, you can do like that. That's what I'm saying. I want to replace it with that. Okay, now I'm running this. It won't give any error. Now it will be executed. Okay. Similarly, for other categories also you can do if any error you got at any time. Like that, we pre-processed all the inputs and we checked each and every category. Like you can replace for remaining categories as well. So unique values, the next you can keep x equals to this one. As we can keep x equals to this one. Why we know not to specify by default if we consider. Let's see count plot now. Yeah, it will give you count of each and every category. So here also you have to specify x equals to this one and y equals to that one. Now you can see. So for each and every feature we are doing this analysis. We have to give y as well. Okay, the next that specific column for that specific column we are plotting distribution plot, how that category values are distributed. Then next we are splitting the data set in the form of training and test set. Okay, so predictors means I'm saying y is nothing but except like predictors means inputs, sorry. So except target column, remaining all are inputs, and target column is our output. And we divided data in the form of 80:20 ratio. 80% of data we are considering for training and remaining data we are considering for testing. We are looking at the shape of the data. 820 comma 13. 820 records we are considering for training and 205 records we are considering for testing. So we are checking the structure. Now we are training the models. So we'll consider accuracy as a final matrix in this example. That's why we are importing that from sklearn. As previously, we applied all the algorithms combinedly, right? Now here I'll apply independently. Initially, I'm taking help of logistic regression and we are performing prediction with logistic regression. Okay. Similarly, we are checking performance score of logistic regression. It is giving 86% accuracy rate. The next naive Bayes algorithm, and we are checking its performance. So it's giving 85%. Similarly, support vector machine. It will take some time to process. Yes, completed, done. It's giving 83.9, means closer to 84%. Now we are applying k-nearest neighbors algorithm. It's giving 72%. The next we are applying decision tree algorithm. The next we are checking performance with this. As it is giving 100%, means it might be overfitted. Okay, so we have to look into that. The next we are taking help of random forest algorithm. It will also give 100%. Why means it's the ensemble learning algorithm based on decision tree. We'll see the performance of this one. Actually, it is running. It will take some time. Like we have to generate more and more decision tree algorithms. That's why it's take some time. After training that, we'll check the performance of that thing as well. Exit boost also an algorithm which is similar to random forest. It is also an ensemble learning algorithm. We are taking help of that model as well, and we are checking performance with that as well. Similarly, we are plotting, we have to plot a confusion matrix. For this project, I took help of ANN as well, artificial neural networks, as you know. Yeah, think I did that? Yeah, prior to that, I'm plotting confusion matrix. I might remove that portion. We're plotting confusion matrix corresponding to each and every type, and we are plotting that thing. At the bottom here, I'm doing same project with the ANN. You see here. So yeah, this heat map, as you know that. Here I'm implementing same thing with the ANN. To implement something with ANN now, like we have to have sequential to flow the data from input to output. We should have a sequential from Keras. The next we have to take help of layers. So models means to flow the data from input to output. We should have models. From models we have to take sequential and layers. So if you want to create any internal layers, we have to take help of layers. From the layers we are importing dense. So now we are constructing the model. So to flow the data from input to output, we are taking help of sequential and we are storing the sequential object in model variable. Then next, we are adding layers. To add layers, we have to take help of dense. So dense layer we are adding. The purpose of dense layer is it is a fully connected layer. So in this data set, like based on the data set, we are taking 11 nodes and the activation function ReLU we are using. Input dimension 13 we are taking. And coming to the final output, we should get a single output, whether it will be a probabilistic value. And for the probabilistic value, we are taking sigmoid as an activation function. As in this problem, we'll be having only two categories. That's why we are taking help of binary cross entropy as a loss function. And I'm considering accuracy as a performance matrix here. So I'm running this thing and we are training the model. So finally, it will give you some output. And I am comparing all the model's accuracies here in the graphical format. You can see